Okay, why don't we get started? Good morning, everybody. This is Roger Royse, the founder of the Royse Law Firm, a business, corporate, and tax firm with offices in Northern and Southern California, and a national and international practice catering to the technology startup community. Today is part of our webinar series. We've been gone for a while, but now we're back with the latest innovations in construction technology. The construction industry is rapidly changing due to advances in IoT, big data, robotics, artificial intelligence, and AR/VR. Today, we're going to learn how companies and contractors are leveraging these technologies to help designing, building, and managing big projects. Before we start, a couple of housekeeping items and some announcements. First, I want to let people know that this is being recorded and a copy of this presentation will be available on the Royse Law Firm Education Hub and also post it to royseuniversity.com. You'll find a recording on the Royse Law YouTube site, as well as the audio available for download as a podcast in the iTunes podcast store. In the right-hand corner of your screen, you should see a chat box. If you have questions, feel free to type in your questions. We'll try to get to them at the end of the presentation. Questions for our panelists, any information you like. If we don't get you your questions today, I'll forward them to the panelists and you can follow up directly. A few announcements before we get started. This is part of a series of events and webinars that we conduct here at Royse Law Firm. Today is Construction Tech. Tonight, this evening, we're going to be in San Diego for a live event on AgTech. San Diego AgTech, it's our second presentation in San Diego. We had a very lively discussion last year when we were down there around GMO and modified genetic editing. I expect because of the biotech sector down there, we'll have another lively discussion tonight. We have a pretty big audience showing up and an all-star panel of AgTech investors and entrepreneurs. I want to let people know that one of our partners, Verge, has got the Verge 17 conference on September 19, where they're going to accelerate the clean economy by bringing together 2,000 leaders from the world's largest companies, government agencies, and startups to discuss, explore, and elevate innovations at the intersection of technology and sustainability. September 20, we are going to be in Austin, Texas for the Austin AgTech, Austin Tech and Agriculture presentation. This is a panel to discuss intersections of technology and agriculture out in Texas. It's our first time there. It's a little bit different market. The Austin scene is a little bit different. As you know, I'm really excited about what we're going to explore in Austin, September 20. Worth a trip out there if you happen to be in that area. October 10, another one of our partners, Precision Ag, will be in Phoenix for the Precision Ag Vision Conference. We're going to explore a full day of ag tech in Phoenix. And finally, October 10, we will be in Fargo, North Dakota, going back to my hometown for an ag tech presentation in Fargo. That's going to be probably one of our bigger ones, believe it or not. And then finally, we are ending this year with a bang. We are doing our ag tech tour throughout China and Asia. We have plans to have presentations, panels, pitches in Taipei, Hong Kong, Shenzhen, Shanghai, Beijing, possibly Seoul, maybe Tokyo. So that'll be in December of this year. Stay tuned. If you're not on our mailing list, make sure you subscribe. You'll hear all about this. So for today, we were talking about construction tech. We've got a great panel put together. We've actually done this presentation live once already, and it's really an eye-opener to see what's happening in the construction tech world, all the developments that are going on, all the opportunities that there are. And today we have a great panel for our webinar. We have Dean Lewis from DCI Engineers, Deepak Gupta from Rock Capital, and Rohit Arora from MBH Architects. Our format here is I'm going to let each of our panelists explain who they are, give you a little bit of a description of how they come to the area, and anything else that they think that we ought to put on the table for discussion today. And then we're going to launch into a discussion. If you have questions, make sure you type them in the chat box, and I'll make sure that we get them in front of our panelists so we can address them here today. So for starters, I think, Dean, that we'll start with you. And why don't you go ahead and take control of the screen. See if I can get that too. Dean Lewis.
All right. Everyone see my screen?
Yep, I see it.
Okay. Let's try and hide this guy. All right, thank you everybody for giving me the privilege to come and present to everyone today. Very exciting stuff going on in the Bay Area, which is where I'm from, and worked for the state and federal government for a little bit, and then now I've been working for DCI engineers for the past few years, and just want to go over some of the construction technologies we see from our perspective, and just to give you some perspective on who we are. We are a structural and civil consulting firm with offices all over the United States, but we also perform work internationally as well as domestically. And really, we work on all types of different structures, anything ranging from wood, concrete, steel, cold form, any type of material. And we really offer value engineering to our clients to help them see what product would best fit their structure or their building, as well as perform performance-based design, which gets us into some interesting projects as it goes above and beyond the code. But what we want to focus on today is just different types of prefabrication and modular innovations and technologies that are being used. And some of these are already prevalent in the market. Precast concrete is obviously one that is used in a lot of parking garages. There's also, as concrete products go, there's tilt-up concrete, which is typically used in warehouses, and really there's just the speed of fabrication of these elements as well as getting them on site to reduce the amount of labor that is needed to perform the construction. And then we get into a Diversicore is a product that we use as well, and it's combining the best of steel and concrete to give us longer floor spans to be a more structurally efficient floor plate. Another proprietary product that we use on our projects is ConnexTech, and the advantage here is that there's no welding, it's all bolted connections, so a lot less special inspections on site, which means less costs for the contractor, and they also go up very quick. Another thing DCI is very familiar with is steel module construction, where maybe it's a cold weather environment or it's a manufacturing facility where they can't afford to have their facilities down for a couple of weeks and they need to perform a retrofit or construction over the time span of a weekend. And so therefore we come up with these full-blown modules to be installed. As far as modular and prefab, there's also kind of a term that is referred to as kit of parts system, and we've really had the privilege to work with Collins Warman Architecture up in Seattle on this project. It's the Sustainable Living Innovation System, and as you can see in these pictures here, your kit of parts building goes up kind of like Legos, where the beams and the columns are put and installed, and then the floor plate is integrated with the MEP and utilities. And so this allows a very efficient project. It's very fast to install, and it's also robust with long floor spans. But then backing down into more of the ubiquitous materials that we use in everyday construction for the majority of our projects, a lot of light frame materials. And even these, we're seeing a lot more prefabrication. We see a lot of prefabricated walls where the wall panels are prefabricated off-site, shipped to site on the back of a truck bed, as you can see here, and then installed. And if we take that one step further, we also do full-blown modular, or as other people call it, volumetric modular. And it's where the whole unit is integrated. It can even have furniture installed if you wanted it to. And so these are installed on the back of a truck bed and then lifted up into place. But really what we kind of want to talk about today is mass timber. And mass timber is a term that is different from what we're used to seeing in light frame construction. Light frame or stick frame construction is what you're seeing in these pictures here, where mass timber is a lot different. Instead of 2x4s or 2x6s that are spaced at 16 inches on center or so, really you have larger sections of timber, usually 4 to 6 inches thick for floor plates and columns or posts and beams that are composed of large engineered wood components. And there's a lot of different types of mass timber, and we're just going to cover a couple of the key players that we see in the market that are coming up. One that is already prevalent and everyone's aware of is GLULAM. This has been around for over a century. It's actually the same technology, though, that's used on some of these other engineered wood products. And it can be, basically, it's 2x members that are put in a one-way span that can make posts, beams, or even floor panels. In the same breath, the product that's been around for a long time is nail laminated timber, or NLT as it's referred to, and you're taking the same 2x members, stacking them up on edge, and then stitching them together with nails to make a large panel which has the prefab capacities. But the real rock star that we see coming on in the market is cross-laminated timber, or what's better known as CLT. And its name comes from its inherent capacities. As a product, you have the same readily available 2x lumbers that are put in a layer, but as you can see in that picture on the bottom left, the layers are crossed perpendicular to one another. There goes the name, cross-laminated timber. And what that does is it gives the product immense dimensional stability that is comparable, or if not better, than concrete and steel, as well as two-way span capacities. And when I say that, I mean that the product can span in both directions, which allows it to compete with steel and concrete buildings. And when we speak of, mass timber buildings, one that's pretty prevalent that DCI was able to work on was the Bullitt Center up in Seattle back in 2012. And this was the first building designed to the Living Building Challenge. And what that means is this building is designed to last for 250 years, which is pretty amazing and changes people's perception of what a mass timber building has the capacity of. And also, as you can see, there's also the aesthetic component, which is another selling point for our clients, as the natural spaces are very intuitive, as well as biophilia, which is a term that basically humans are able to relate better to nature than they are to a cold concrete or steel surface. And therefore, they've actually done studies where they've gone into schools and hospitals and have found that the wood aesthetic is able to help patients in hospitals heal faster, and kids in schools or students actually have lower levels of anxiety and perform better on tests. And so if you want more information on that, I can definitely send those tests to you. The other inherent quality is that timber is a lot lighter than other products. You can see here an example with concrete. Concrete is about 4 to 5 times heavier than a mass timber product. And that really gives itself an opportunity for buildings because it's going to have a lot less weight, a lot less mass that we have to dissipate in terms of a seismic event, as well as you're spending a lot less money on the structure itself as far as columns, foundations, especially when it comes to piles. And the other inherent advantage is the speed of construction. That's a major issue that the construction industry faces today, is not only the labor component, but also the speed component. And if you look at here, this is a typical, concrete construction site where you have to lay out the formwork, put out the reinforcing. You're typically using PT, then your stud rails and MEP. So it's very convoluted and a lot of labor on site. Whereas you look at a mass timber building site, these are 10-foot wide by 40 to 60-foot long panels that are shipped on the back of a truck bed, lifted in the site with a crew of only 4 or 5 individuals that can lay out a 30,000 square foot floor plate in a week. So it's very efficient and very accurate style of construction. Not only that, you're pulling from a larger labor pool. The construction industry is seeing a lot of shortages in specialty labor such as welders or iron workers. And here you have carpenters, which are using more ubiquitous tools such as hammers, saws, screws, and nails. And so where we're at right now is we're actually limited in our building codes at 85 feet. And we've been working with jurisdictions and in other cities on getting an allowable height increase for some mass timber buildings, as well as building more stories in mass timber. But the overall picture I guess I would paint is that mass timber can be used in all types of buildings, smaller podium structures up to 85 feet. And really the mid-rise option is kind of what Europe has been practicing for the last 20 years. And that's kind of in the 8 to 12 story range, as well as now the UK and Australia have picked up on it. And I'm sure that you've heard from the media a lot of talk about high-rise mass timber structures. But really, and there's a lot of studies that say that by the year 2050, the majority of our world's population will live in cities. And so to densify those cities, we're going to have to build with taller structures. And what we see is that with mass timber, you have the speed of construction aspect, a smaller labor force that is being pulled from a larger labor pool, and it's also a very sustainable and resilient material. So I'd like to talk more about that today in the panel, but if you have any questions, you can contact me at the following email and phone. and I will pass it back.
Okay, thanks very much, Dean. Why don't we go ahead and give this back? There we go. And Deepak, do you have a few words that you can provide from the investor standpoint on construction tech, especially the startups that are fueling these innovations?
Well, first thing I want to say, Roger, thank you for hosting this panel, and I'm looking forward to healthy discussion. Dean, great job on the presentation. It's good to get some information on DCI engineering. Again, my name is Deepak Gupta, managing partner at Rock Capital. I'm also an operating partner at Bessemer Ventures, and I also do some work with Berkeley Haas. I help a lot of entrepreneurs coming out of UC Berkeley in general, but specifically Berkeley Haas, and we work with startups anywhere from idea all the way up to seed stage. So why am I here? I mean, basically, I do a lot of work in the IoT as well as the drone technology. The three areas that I'm excited about is actually machine learning and AI and how it's going to change construction tech, as well as generally the IoT, things going on in homes, the technology, as well as from drone technology. I just talked to a company more about doing inspections on roofs and how drones are helping facilitate that. So basically, yeah, I'm looking forward to the panel, and I'll give it back to you, Roger.
Okay, thanks very much. And finally, Rohit Arora from MBH Architects. Are you there?
Good morning, everyone. Yes, I'm here. Okay, can you hear me?
Yep, hear you fine.
All right. So my name is Rohit Arora, and I'm an architect by education. I practiced as an architect for about 5.5 years before I decided I'm going to be true to myself, and I pursued the path of technology. But I didn't go too far away from architecture and design and engineering, which we term as AEC industry, anytime in my career. So I went on a parallel track to technology, and I'm still associated with architecture and design and engineers on a daily basis. So my journey took me to the consulting side, where I consulted for many firms. Then I became a QA engineer and worked with Autodesk for some time, on the other side of creating the software and testing it out. So I was in the QA department for AutoCAD. And then I completed my master's in business administration from UC Davis, and then decided to try out my luck in the Bay Area with 2 startups. And in fact, both the startups were sort of linked to design and construction technology themselves. So right now I'm helping out MBH architects find their way through this this whole thing that's happening with construction technology, and construction is ready for a disruption, I would say, in terms of embracing more technology so they become more efficient. So that's what I bring to the table, my background as an architect and my love for technology. So for last 1.5 years, we have taken a deep dive into VR, not so much into AR as yet. I think AR is still developing, but we have embraced virtual reality to an extent where we are figuring out how to incorporate virtual reality into our workflows. So a lot of projects as architects do, traditionally, if you look back 10, 15 years or even 20 years, the art of presentation or winning a job from the client or getting paid, you had to take a separate bucket for doing non-billable work. So you would do your drawings, but the 3D modeling, the presentation was separate work. Now the technology that we have embraced, and we have in fact borrowed a lot from the gaming technology company. So we have gaming engines which we plug into our daily software like Revit, SketchUp, Rhino, and all you have to do is make that connection, and then you can take your virtual design into virtual reality and then use the gaming engine to really show you how it's going to look. And as soon as you put on your headset, you are immersed into that environment even before it's built. So the reason architects are falling for it is because you have an immersive technology that gives you a real-time feedback of the scale, of the materiality, of the light. And I think there's no looking back, and we are trying our best to incorporate it into every workflow, every project type that we have, at least for our type of work that MBH Architects does. And in order to approach virtual reality, because it was such a new thing, it's still pretty much new for a lot of firms, my approach was to break it down into what I call is a t-shirt size. So depending upon the need of the project, the scale of the project, and how much budget and time we have, I divided into 3 categories. So t-shirt size of small, medium, and large. When we do small, so small would mean we do some 3D panoramic renderings and do some 360 images. So Roger, I'm going to send you a link which you could probably share, but what we do is a simple version of 360, which is viewable on your mobile device or even on your PC screen. So I've just sent you a link which you can share. So starting from that, that's very small endeavor into virtual reality. So you take a 360 site picture, or you have a 3D model and you create a 360 panorama out of it. You can send that over to the client and they immediately understand what the project is about. Then we go to the medium level, which is a live virtual reality walkthrough. So in that case, we bring the client into our office space. We say, you take on the HTC Vive or the Oculus Rift headset, and then we let them be immersed into the project environment. And then they can walk inside the space, they can feel it, they can change the lighting, day, night, time of the year, and even take a look at changing the materials. So that's the medium level. Then there's a large level as well, which we use on rare occasions with specific clients. And because we serve a lot of local retailers and high-end retailers, we go the extra step of creating an interactive virtual reality demo. And this is an in-house session where we bring them in and we make a virtual mock-up of a retail store where you have virtual wares or objects or whatever they're going to sell in that retail environment placed inside the virtual environment. And we allow them to interact with it. So a store designer can walk in, pick up the objects, and put them the way he or she desires, and then even interact and change the marketing banners inside their store. So we are getting there. We are just getting started on this interactive virtual reality environments, and we've got good feedback. It takes a much more effort, but I think as the technology improves, this will get better and better. The other thing I want to mention is we have started looking outside of the AEC industry for getting inspiration or understanding technology. AEC has been a little slow in adapting technology. Other companies do go, or other industries go much faster than AEC. But the only way to go would be to look outside of AEC. So a couple of examples I can say, VR itself, virtual reality itself is coming from the gaming industry. AEC was late to adopt it, but now that we're going there, I'm really happy about that. The other example I can cite is our use of software like Jira, J-I-R-A. Jira is very well known in the software development circles, and we have adapted that for example, for onboarding. When we hire a new person, we use Jira to do the onboarding, make sure everybody is on track on the same page. So for collaboration, for task management, project management, we went outside of the industry to look at other tools. We are also using Jira for training purposes. So how do you train somebody who's come on board? We do a tracking system. So we created workflows, 30-day check-in for a new hire, then a 60-day check-in, 90-day check-in, and make sure that they are well suited for the work they are assigned to. So that's the key for the future for AEC, looking outside of the industry and then embracing IoT, AI, and machine learning or visual learning, for example. Maybe tomorrow we can look at machine learning, learning about just scanning a space and understanding the changes that are happening in the environment. So I'm really excited. There's a lot to do, but the key is to look outside of AEC all the time.
So Rohit, what was that term? Was it AC? You said you're looking outside
of AEC, so architecture, engineering, construction. So
architecture, engineering, construction. Okay.
Yeah.
All right. Well, thanks very much for that. You know, I'm going to Deepak. I'm going to come back to you for kind of the lead-off question. Is we've kind of gone through a lot of technologies here and a lot of applications. For our audience, as an investor, what to you looks really hot? What's investable? Where do you see some really big opportunities in this space right now?
I mean, for first, I'm really excited about AI, and we can talk about AI in a different segment altogether. But in terms of technology that I see is probably drones and how the drones are being applied to construction technology, whether doing surveys, whether they're actually even doing inspections, you name it. I mean, I've seen so many different drone technologies going after this space, and both from a hardware perspective for the drone as well as a software perspective, just getting the data, analyzing the data, and providing that to people in the field. I think that's going to be huge. And right now, this technology is still very fragmented. There's not a clear leader in this technology, and you could see different people going from, you know, every different angle you could think of in trying to attack this.
Okay. Anything else that you're really excited about?
Yeah.
You know,
go ahead.
There's one thing I want to ask you about specifically is I'm hearing a lot about materials, modular building, and even the presentation that Dean did. It seemed like the materials side of this is getting to be very advanced, and not only just the materials, but also the design. It's really interesting what Dean was saying about how, you know, having earthier sorts of buildings and, you know, makes for a better experience. Is there something in there that you see that's investable?
Well, absolutely. From an investable standpoint, there's always new technology, what's going on. But the way we're looking at it is more from the return perspective. And I think right now, the material side of it, and Dean, please correct me. I mean, yeah, you're working with this a lot more than I. I just don't see something that people are saying, this is it. You know, this is going to be the way we can see a lot of units being produced, or this is a material that's going to really get people excited. I don't personally see a clear leader in that, and until then, I'm kind of not as bullish on the material side of it as maybe somebody else.
Well, tell me about prefab and modular and 3D printed buildings, things like that. That's something I've been hearing a little bit about, and I'm really curious because it sounds very interesting. Is that really a thing? And is that happening? And is it making construction more efficient and cost effective? Can anybody speak to that?
Well, absolutely. I'll start off, and Dean and Rohit, maybe you can tag along as well. But it's one of those things that I do see the shortage of, as Dean had mentioned, you know, people in construction. And anything that can make the process more efficient, and we can actually build more units and faster and more modular and increase that, I think there's something definitely there. Again, in terms of a clear leader or a startup that's doing this work, there are a couple of companies that are coming out of YC trying to approach this, and let's see how they do. In my view, construction technology is very hard in terms of getting the adoption and getting people to actually change their behavior. It really needs to come from the top down, but sometimes it also needs to go the other way, from bottoms up. If there's a technology that's, you know, for example, on the mobile phone or whatever, where everybody has it, it's something that's easily penetratable, and you could actually increase the user base. Something like that is, you know, easy to deploy. than trying to, saying, hey, this is the new way to do everything from top down. But anyway, guys, go for it.
I'll just say on the prefabrication and modular aspect, from an investor standpoint, I think there's definitely a lot of interest there. We've seen a lot of that in the Bay Area. It's becoming more and more prevalent. We do a lot of different types of prefab and modular, as we showed in our slideshow, and there's a lot of private companies that are a lot of technology companies that are investing in factories and want to actually produce their own housing because there's such a housing shortage issue. And if you look around the nation, there's a lot of housing shortage issues, and there's a lot of different markets. But I will go back to say that it is interesting that materials are hard to get into the market. Like Deepak pointed out, it's hard to get materials to be accepted. And the one thing I will say is about mass timber is there's a lot of actual federal incentive and a lot of federal money that's being pumped into the research on this material in the past decade. And now it's been adopted into the codes in 2015, the International Building Code. And so now it's really gaining momentum. And if it continues, we can see something like what the Europeans have been using it for the past 2 decades, and even the United Kingdom and Australia have really picked up on it. And it's just another solution for a potential investor if they're interested.
I'll add to the aspect of technologies that we are already kind of exploring, like 3D printing. We do employ 3D printing in-house, and it's, I think, the economies of scale that we don't have a large or a practical 3D printing ability to manufacture large scale things. But I think I can imagine in a future where you have a 3D printer or something similar on site, which is fabricating as you need. And that is the vision, I think, that we are looking for, where we're already modeling buildings. So the terminology we use is called BIM, Building Information Modeling. So the data is all with us when we design it virtually. And right now there's a lot of waste when we convert that 3D BIM information to flat 2D drawings and then send it to the site. And people who are in the construction, the subcontractors, contractors, interpret that information and then build the 3D model back again, which is in real full scale. So the vision would be, there is no loss in the conversion. You send the data to the site, and the building elements are manufactured right on the site, and people can erect that. So that's the vision. I hope that's the way industry goes, because 3D printing allows the option for us to, first of all, we do it at a small scale. We can test it out, do the designing, prototyping, and then send it to the site for the real 1:1 scale manufacturing. So that would be something that's going to really change things. But more and more, I'm seeing the industry is becoming very data centric. So at some point, every design company would be a software company in some ways, and then the output would be physical. So I'm really excited for that future. I don't think it's too far away, but as things go in this industry, it's very slow adoption. So I'm looking for a disruption myself. I was part of a company which was doing modular design out of a factory, and I'm hoping that those kind of companies grow and become mainstream.
Let's pause on that for a minute. That's really interesting, this concept of BIM, Building Information Modeling, and what you just said about how the adoption is relatively slow, because construction is a huge industry, and I understand that a lot of the costs in construction are due to rework, too many moving parts. You got coordination issues, field to office, human errors, all the stuff that you would think could be solved through really efficient modeling. And I understand, and from your presentation in particular, Rohit, I understand that that BIM is something that's being led by the largest software providers in the sector. Autodesk, I think you mentioned.
Yes.
What is it that is having so much trouble moving from the design table to the field, and is that changing?
I just went to Toronto for a conference a few weeks back. It was the DTS conference combined with the BUILT, and then this was North America. So people from all over North America got together, and we were discussing something similar, and we felt BIM has reached a plateau for, it's been around for 10, 15 years now, and Autodesk embraced it in 2004 or 2002, I'm not sure, remember exactly, but it's been a while, and we've hit a plateau, and it's not because of the software, it's more like the weakest link is the way we have to deal with agencies who are still not up to stuff with the technology. They want 2D printouts or they want PDF deliverables. So we have to convert our fully baked information model down to the 2D flat level PDF drawings, which they mark up, and then we have to, so there's a lot of back and forth, and we lose. So I think we have to, the whole industry has to move up, and I think we are being dragged down by the weight of local agencies who need different deliverables, who need a certain number of copies in print. So those are the kind of things pulling us down. I'm really hoping for a place where all these barriers are not there and people can go directly from modeling to fabrication. The other aspect that surfaced was the lack of trust between the different groups. So you have designers, architects, then you have subcontractors, the client, and the lack of trust and the fear of, being held accountable for a mistake. That's what's holding back the industry as well. That's why we're not able to go from modeling direct to fabrication. We have to do all these translations, get it stamped, and then reconstruct. So a quick example would be the architects make a BIM model. The general contractor will build their own model from that. They will not trust the architecture model and vice versa. So there's a lot of trust issues in the industry. So I don't know how we address that, but we'll have to do it together.
Okay, any other comments on that topic before I move on from our other panelists?
I would just piggyback on what Rohit said. It's we had experienced that a lot on our end too, and like Rohit had mentioned, the contractor builds their own model, and I guess just for the audience's sake, that there's the architectural model, there's the structural model, there's a civil, there's a mechanical, electrical, plumbing. Most of those are kind of conglomerated into one model, but a lot of times they're all different, and the question always comes is whose responsibility is it to discern the conflicts between the models? And so I think it depends on the project and the owner, but that's definitely a true issue at hand that faces the industry right now. And then as far as taking something from a digital aspect to the physical world, I think a CAD CAM technology, and that's computer animated manufacturing, and we see that a lot in the European and Canadian projects, but it hasn't really come down into America yet. And I think once our labor costs continue to rise, it's going to become more of a solution for the market.
Okay, great. Rohit, the other thing that you kind of hit on, and I'm going to go through some kind of specific applications and technologies now. The other thing you mentioned that I think is really interesting is the idea that about data and data collection and how design is becoming software. Yes. For any of our panelists, can you talk a little bit about what are the opportunities in data? What kind of data is being collected, and how can it be useful in this business? Anyone want to jump in? We can.
Yeah, I can get it started. So a lot of data is going to be collected, and it's already getting collected, but there's going to be more and more as we start implementing IoT into our buildings. And from the design side, at some point, the designers will have to think about these bits of technology which will go into our buildings to collect data on an ongoing basis. So, and at that point, the people who manage the facilities or the facilities management groups will really have a lot of data at hand. And so we need some sort of a loop, feedback loop there. You collect the data, and then you need to understand what to do with it and how to build better buildings or better environments based on that data. So it's going to become a big data problem, and that's a good problem to have. So I think we'll have to learn how to take leverage of that.
So I'm going to jump in as well, Rohit, and kind of add to that. And I agree, the data that's coming out of IoT is already tremendous. And I think this is back to my original point about AI. What I see companies doing with all this data, instead of giving it to the management company locally, can we automate a lot of this stuff, from controlling the heating, cooling, lights, you name it. I mean, in terms of just getting AI involved in just doing this without any users getting into it. Again, coming back to the data point and how much data is being generated and how fast can it be computed, this is a tremendous opportunity that definitely gets a lot of VCs excited. And just thinking of what kind of IoT is actually going to lead this group in terms of, okay, does it make sense to go for a sensor technology or something else? But again, I think data is the key in all of this.
Right.
And I would just add that on Deepak's point, yeah, there's already technologies that are being used where building systems are being automated as far as energy performance. You know, energy is going to be it always is a huge issue with buildings and how much money is being spent on a building's longevity. And they already have, you know, sensors in place that can tell, you know, how many employees are in the building this morning. Have they logged onto their computer yet? How much energy do we need, you know, to run for today? Do we need to clean the solar panels to, you know, have more energy intake and stored in our batteries for tomorrow? Because we know that tomorrow's, you know, Thursday or Friday. I mean, so there's already from an energy standpoint as far as lights, heating and cooling, and then also water systems as well. So it's very exciting, the IoT of things for buildings and energy.
Yeah, and it sounds like these are all technologies that are going to make construction more efficient and cost effective, including the data applications. Let me talk about a couple other things. I heard somebody mention drones, and I'd like to hear a little bit more about that. Is this a trend? Is this something that's being widely used, and how are they used in, I guess, in DIM and 3D scanning, reality capture? Anybody want to jump on that?
Since I brought it up, I'll jump on it initially. I mean, drone technology, what I've seen in especially insurance and what we're doing right now currently, if you look at buildings, commercial buildings, nobody, I shouldn't say nobody, but hardly many companies are actually going after inspecting the roof. They're actually going inside the buildings or outside, and they're just looking at the building when they inspect the building. What drone technology is helping a lot of these insurance companies actually going on top of the roof and inspecting everything before they actually insure a building, as well as after a, you know, any kind of catastrophe from hailstorms or whatever else. Being able to not physically send people up there is a very big plus for these insurance companies, as well as just getting that data. I mean, now with drone technology, you could take, you know, 3 pictures or 4 pictures every, you know, 10 seconds, 15 seconds. So you can get a lot of, again, coming back to data and then analyzing this data and giving an accurate assessment of what's actually going on. So I'm really excited how drones are changing technology, construction technology in general.
I would agree to that. So there are a lot of applications. You know, I've seen a demo where a drone will be, for example, on a high-rise, is just going vertically up, scanning the building using a thermal scanner, and that's a good way to find a thermal leak. So where is the building losing energy, for example? There's a heat, thermal leak somewhere on the building. So those are kind of applications where, without putting a human being's life in danger, you can apply drones. There are other applications similar to, for exterior sites, large sites, and getting 3D modeling done or existing conditions. But one thing we ran into, because the way our firm works, 80% of our work is in interiors, and there's only a 20% use of, we do some housing and large-scale projects, but most of our work is indoors, and that's where drones are unable to work because of their lack of GPS availability. Because when you're inside the building, you can't track a drone. So we are looking at options. Okay, if the drones cannot be controlled through positioning indoors, can we use some indoor positioning capability? So we're still looking for a solution, but for now, what we do, we use laser scanning for reality capture. So that's something else we're looking forward to in future.
I'm sorry, what was that last term you used? Did you see laser scanning?
Yeah, so we use laser scanning.
Can you explain what that is and how that works?
So laser scanning is basically a tripod which has a laser scanner, and you go to different spots. There's another product, in fact, Matterport was there in the last panel, and Matterport is something else that we have looked into for scanning large interiors. Even when they can basically make a virtual model of the existing space, and that's a very good way to see the current space, and then you can redesign it from inside and take measurements. So you don't have to go and measure out everything manually. Using laser scanning and reality capture, we are able to get a good, accurate model of an existing space. And this really helps in spaces where you have large mechanical pipes going in the ceiling, and it's impossible for a human being to measure those. So a laser scan will provide us a full 3D model or a point cloud, which we can bring into our building information modeling or BIM project. And that way we avoid clashes from the very get-go. We know what's already in the space, and we have to work around that. So that's the kind of technology we are already using on a day-to-day basis.
Okay, got it. Thank you. So let me move into a couple of, I guess, unless there's any other technologies that we want to make sure we mention here. I've got a couple of broader policy questions to talk about. Is there anything else that we definitely want to mention here that we haven't already?
I can mention one more thing that we are just recently looking into, and that is using virtual desktops, basically running our computers in the cloud, and we have looked into a couple of solutions. So this is a good way for us to have disaster recovery and scenarios where we have remote collaboration going on. And because the building information BIM, the BIM models are so huge, we are looking into this solution where we run everything off the cloud. So this is something that is quite new to us, and I think we are going forward with that. The other thing that was preventing us going there was our need for a high-end graphics card. So now that NVIDIA has come up with virtual graphics cards, virtual GPUs, we have started employing that. So we can run very high-end graphic-intensive applications in the cloud now.
Okay, great. Thank you. So the bigger issue is here in the Bay Area, we're all concerned about the cost of housing and the cost of real estate here generally. And I don't know how much of that is due to construction or construction costs. I drive up and down 101, I see a tremendous amount of construction going on. And I'm wondering if the developments in construction tech, if the future of these new technology developments are going to ease some of the pressure we have on pricing around here. Any thoughts on that? Is this going to solve our housing crisis or our I guess in my case, the rent crisis as things get more and more expensive?
Yeah, and I think that's one thing that I definitely bring up to developers and municipalities and trying to work with the jurisdictions to adopt progressive code limits for different types of construction, because right now for most developments, and there's also in the recent fires which have happened around San Francisco on a lot of light frame structures, and so that's why we try and work in mass timber more and more, as it's a more robust product for moisture and fire as well, and just to give the construction industry another option. We're not saying that it's going to solve all the housing options, but to give another option to compete with concrete and steel, also pulling from a larger labor pool with a more capable working force. Those are going to, plus the capabilities of the prefabrication of the element, so it's able to be installed, these buildings will go up quicker. All those aspects will help hopefully provide a solution that can help ease the housing problem somewhat.
Any other comments on that from our panelists? Okay, and then the second big thing that people always talk about whenever we see this sort of disruptive technologies being developed it's become an issue that I guess we just have to mention it now. Is how is this affecting the labor? How does labor play into this? In some sectors, there's a labor shortage, so the fact that these technologies might be replacing labor is not a big deal. In other sectors, it becomes a problem because it displaces jobs, and there's a lot of resistance, especially governmental resistance or institutional resistance to the adoption of technologies just for that reason, because it's really displacing a job market where jobs are needed. Is that a factor in this? Has that been important? Has the technology been a positive or a negative when it comes to employment and labor and job displacement?
I would say, at least for the architecture industry, we need people. We still need a lot of people to get the work done, and it's sometimes cyclic also. Depends upon the amount of work we have, but we are not at the point where we can just do more work because of technology. It also takes very specialized skills and people with a certain level of computer skills to handle all the software that we have in place now. So it's getting more and more specialized, I would say. You have to be able to pick up so much software nowadays, whereas earlier you just needed to understand the profession in some ways.
Got it. Okay, so I want to remind everybody that if you have questions, you can go ahead and on the right-hand side of your screen, there's a dialog box. Go ahead and type your question in. One question we have is the question is, what software is being used mostly today to design 3D modeling and in BIM projects?
I would take that question, and the answer would be Revit. At least in the United States, it's Revit. It's an Autodesk product, so R-E-V-I-T. In Europe, you would have ArchiCAD being more prevalent.
Revit and AutoCAD is the answer.
No, ArchiCAD.
How do you spell that?
So Arch, A-R-C-H-I, CAD.
Okay, I get it. Got it. Okay, let me go on to the next question here. Hold on here. Sorry, software. Revit and ArchiCAD. I'll type it into the chat box so people have that. What do you guys see as the future of construction tech? I mean, I've heard a couple of you make reference to the fact that adoption has been a little slower than maybe we'd like to see, and things haven't even though it's a humongous industry, things haven't picked up as quickly as we might think, and there have been some technology challenges, especially for drones. But what's the future? What do you think the next 5 years will look like? And I guess I'd like to ask each of you to go ahead and take that.
Sure, I'll start at that. I mean, in the next 5 years, I think the prefab model of actually going after and building buildings would be definitely there. And the other part of it would be the IoT and actually going in, actually getting the sensors and technology actually implemented. And this is all from residential homes. I've seen a lot of IoT companies going after this, as well as commercial buildings. So I personally feel from a construction standpoint, there's a lot of different technology that's going to actually impact construction in a good way and actually make it more efficient.
Yeah, I think Deepak really hit on almost all the main aspects that I see in the next 5 years and maybe beyond is the prefabrication and modular element, because we do a lot of that work in the Bay Area and across the country, but it's not as prevalent as it maybe will be in the next 5 years, and that'll just be due to the increased cost of construction, labor shortages, and such. But once we figure out those issues, then the next issue I see as being kind of the IoT coming into buildings and helping, regulate, how much insurance costs are for buildings, how the longevity of a building itself, and the overall energy costs for a building. And so once we solve kind of the labor and the cost of construction issue, it's going to be, well, let's look at the long-term implications of the built environment as well.
Rohit, any comments?
I would follow up yes, that is that. Prefab would be in place. My thinking is a little bit more utopian, or I would say, in some ways, I have a feeling that virtual reality will affect the way the customer of the future will demand for housing. They may not need that much of a big space, because virtual reality, when you get immersed in it, you don't feel the lack of space. So I don't know, this is my gut feeling. I'm saying that the demand of housing in the future might be different. The next generation may not need that much space. They may not feel the need for bigger homes. So, but I don't know, we definitely need physical space, because virtual space will not help us there. But it may be a different place in 5 years, as companies like Facebook and Google, they're pushing for virtual reality, augmented reality. I think people will create the space in the same room. So it might be a different future. I don't know.
Okay. Well, with the last few minutes that we have, I'd ask you guys if you have any closing remarks, and if there's anything else that we'd like to let our audience know about. In the meantime, we do have a question box if our audience has any questions, and we can take them in this webinar, or I'll go ahead and put you in touch and we can take them offline. There are some materials, some links that I've blasted out to everybody through the chat box, so you can take a look at the materials offline, and we do have a few slides here from Dean. But closing comments, let's start with you, Dean.
Yeah, I would just say Rohit kind of touched on it. One thing I forgot to mention is the next few years there's going to be continued constraints because of, jurisdictions being, tighter. We saw the issues with the Millennium Tower and such, and then you have the labor issues, but also the community as well. You're going to have a lot more people, a lot more transportation issues, and a lot of more transportation-oriented projects that are going to be coming about to help, facilitate a growing population. So a lot of challenges that'll be proposed to the industry, but hopefully, with technology and new innovations, we'll be able to supply that demand and meet the needs of the community and the public.
Okay, Rohit.
I would say agree. The time you spend on roads nowadays in the Bay Area, something will need to happen for that. It's not sustainable. So there would need to be a slightly different model, and I think transportation is going to be a big thing. Self-driving cars. Accordingly, you will have some other way of working around this. It's not sustainable. So a lot of focus on that.
Okay. And Deepak, you get the last word on this.
No, I appreciate again the time, Roger, and good meeting both of you, Rohit and Dean, online. I just want to close by saying I think it's exciting times in innovation for construction. I think there are a lot of changes that are coming. Some might be within 5 years, some might take a little bit longer. But I think in terms of IoT, again, and as well as modular designs, there's a lot of things that's going to happen. And it's just bottom line is things are going to get more efficient. So I think once things get more efficient, there's definitely, it's going to help a lot of people as well as try to make money from it. So I think that's it.
Okay, well, with that, I want to thank our panel. Thanks very much. Very interesting. I think we're going to hear a lot more about construction tech in the future. For our attendees, thank you for tuning in today. Again, this webinar has been recorded, so you can refer back to it. There are materials that have been posted. You'll find it on the Royse Law Firm Education Hub as well as Royse University, and available for download as a podcast in the iTunes podcast store. Stay tuned. We do this frequently, both webinars and live events. As I said, our next few events are San Diego this evening on AgTech, Austin, Texas next month. Fargo will be in October, and then we're doing a complete Asia tour this December. We record all of these events. We post them on Royse University and the Education Hub. So if you can't attend live, you can watch the recordings. So with that, I'm going to conclude the webinar. Thank you again, panelists, and thank you, attendees.
Thank you.
Thank you.
Thank you.